Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Now, today is the second part of a two-part series where we're taking a look at the new SmartRail Ethernet I/O base. Here's our specific topic for today: the new SmartRail Ethernet base and Ethernet IP. Now, last week it was all about using the new SmartRail base with an OCS control system as the easiest plug-and-play method of adding Ethernet-based I/O to your OCS all-in-one controller. Now, to help us explore using this same base with Ethernet IP, I'm going to bring in our product manager, Mr. Casey Gardner. How are we doing today, Casey?
Hey, not too bad. How's it going, Chuck?
It's going great. Now, you just heard me describe the use case for using the new base with a Horner OCS. What would you say is going to be the common use case for using it in an Ethernet IP environment?
Sure. So there's definitely some cases where, whether it's OEMs or integrators, again, they may be using Horner OCSs with their machines or different various systems, but in some cases they may be using another PLC as a front end, such as a Rockwell, being it so common with Ethernet IP. So in that case scenario, that may be a time where, again, they're controlling the front end and they just need some remote I/O to add onto the system, and that's where this product fits very well.
Yeah, that makes a lot of sense. So you can potentially use the same components, the same I/O system with both a Horner-based control system and, let's say, a Rockwell-based control system. That sounds pretty good.
Absolutely.
Okay, so I have to ask you one more question about Ethernet IP. So for years, Horner has supported Ethernet IP as an I/O adapter, so you can take any OCS and hang it on an Ethernet IP network, and it can exchange I/O with the Ethernet IP I/O scanner. And then we've also supported exchanging tag data with the Rockwell Logix CPU also over Ethernet IP. But what we don't have the capability of doing inherently or built in is acting as an Ethernet IP I/O scanner. So what do we have any plans to add that capability inherently to an OCS?
Sure. I wouldn't completely negate it, but as far as our general demand for it is not necessarily in the short term, I would say. We definitely have had some customers ask for it here and there, but for our vast majority of our user base, they have not, especially for controlled cases such as using VFDs or again, other sorts of drives. Basically, there's a lot of existing protocols such as Modbus or Modbus TCP that we've supported, or other protocols for that matter, that they're able to use with our products today, for sure.
Okay, well, that makes a lot of sense. So for those of you where having the OCS act as an Ethernet IP I/O scanner, if you see that as really important, give us that feedback, whether it's in the comment section or the chat section, or whether you send an email to Casey or myself. We'd love to hear your feedback as Casey prepares kind of the plans for this year and beyond. Okay, thanks for your insight, Casey. We'll talk to you again next week.
Sounds good.
All right, let's take a look at how we're breaking down today's topic. Okay, we're going to start with a really quick review of Ethernet IP. We're going to talk, of course, just briefly about why we would use the SmartRail ETX250 with Ethernet IP. We pretty much covered it in the opening with Casey, but we'll spend a minute on that as well. And then we're going to go through the complete configuration process that you'll need to take. And we're going to specifically give you the details if you're using a Rockwell PLC, which is pretty much most people who are watching this video, I would imagine, are looking to use SmartRail with a Rockwell PLC. And then after we kind of walk through the steps, we're going to give you a full hands-on demonstration from A to Z. Okay, let's get started. Ethernet IP. You know, what is it? Well, it's one of the most prevalent industrial Ethernet networks anywhere in the world, but especially in North America. And it's especially popular in North America because Rockwell is popular in North America. It's the Ethernet network that they primarily drive in terms of what they support and what they promote. And because there are a lot of Rockwell users out there, there are a lot of people using Ethernet IP as well. Now, OEMs are often compelled to use Rockwell products on a project because end users often insist. And in those scenarios, they have no other choice but to use often Rockwell CPUs, but they often have more flexibility in terms of some of the accessory products they use, the I/O, the HMIs, the PID controllers, those sorts of things. There's often a lot more flexibility. So very often you can meet a spec as an OEM by using a Rockwell CPU, but using third-party components like I/O, for instance. And currently, in this current supply chain scenario, Ethernet IP remote I/O is certainly one of the things that are in short supply. So that's another reason why using SmartRail with Ethernet IP makes sense, because of the supply chain scenario. Okay, so now let's talk about SmartRail. What is SmartRail? Well, it's an excellent remote I/O option for a variety of applications. It is a modular system with a I/O base and then up to 8 modules per base. And there's all kinds of different modules available. Certainly the most commonly desired modules are available. You've got DC inputs, DC outputs, relay outputs, analog inputs, RTDs and thermocouples, of course, analog outputs. There's also a mixed analog option as well, okay? And the most popular, you can see it's available in all these different densities. For digital, it's 8, 16, and 32. And for analog, it's primarily 4-channel, although we do have an 8-channel analog in. But one thing I want to mention before we move on, and that is, I would recommend, if you're looking to use SmartRail, especially with Ethernet IP or just in general, I would highly encourage you to go with the standard densities of 16 points for digitals and 4 points or 4 channels for analogs. The reason, there's a couple reasons for that, but the most important reason is those are the modules that have the most inventory. So those are the ones with the highest usage. Those are the ones we inventory the most. So if you're looking to use SmartRail and you want to make sure it's available, use the most commonly used densities that I've highlighted here on the screen in yellow. Okay, so the use case, of course, for using SmartRail ETX 250 with Ethernet IP is the fact that you might not be able to get the Ethernet IP I/O that you normally would use, maybe in the past, and you're looking for an alternative, and the ETX 250 is certainly an alternative because it can automatically detect whether it's connected to a Horner OCS and communicating with that, or whether it's communicating with an Ethernet IP device. So there's nothing really you have to do, flip a switch or anything like that. It'll just automatically detect it, all right? And because at Horner Automation, our team in our purchasing and production control and production forecasting and all those sorts of things, our supply chain team has done a better job than most. So the SmartRail is in a pretty good spot in terms of supply as of early January of 23. So now let's go through the process you're going to need to follow when you're going to be configuring an ETX 250 as a remote I/O base on Ethernet IP. And you're going to do this configuration more than likely with RSLogix 5000 because you're probably looking to add I/O to a Rockwell system. Okay, so the basic steps are kind of summarized here on the screen. Okay, you're going to need to assign an IP address to the ETX 250, and it uses boot P typically. You're going to need to add the ETX 250 to your Ethernet IP network. You're going to need to create tags for a configuration message that contains configuration data that will be sent to the ETX 250 to tell it how to set up the I/O. You know, if you've got an analog I/O block, you need to tell it how you want that to be set, you know, what the format is of the signal coming in and maybe how you want to scale the signal, those sorts of things. Then you're going to create a message block in Ladder that's going to send that configuration data, set your configuration values as appropriate, and then execute that message block to send that configuration data shortly after power up. That's the basic steps involved. Now, to go through the details of each step, this is what it looks like. Now, don't worry. We're going to show you in a hands-on demonstration how to do this in the RSLogix software, but I want to summarize it first so that those who are looking as kind of a reference point after the fact can freeze frame on these particular slides to see what they need to do. So the first step is to assign an IP address to the ETX 250 using a boot P utility, and Rockwell has a boot P utility kind of included in their package. So we'll show you how to use that as well. But effectively what you're going to do is you're going to look for the ETX250 to pop up in the utility, and then you are going to assign it an IP address by creating what they call a relation. And then once you've done that, now the ETX250 has the IP address that you want. So that was the first step. The next step is we need to add the ETX250 to the Ethernet IP network that's in the IO configuration area of RSLogix 5000 in your project. And you're going to name that ETX250 with a name that you want to give it. You're going to assign the IP address. You're going to set your assembly instances to the appropriate values. And then you may want to adjust the requested packet interval, which is the update rate, to a different value. 10 milliseconds is the default. It's generally just fine. That's what I'm using in the demo that I'll show you in a little bit. So the third step then is we need to prepare a configuration message for configuring the SmartRail. And that means creating a couple of tags. The first tag we need to create needs to be of the message type. The second tag we need to create needs to be of the byte variety, and it's a byte array, and it needs to be of the number of total bytes of configuration data that the SmartRail is looking for. Now, SmartRail uses 4 bytes of configuration data per module. So if you've got 8 modules, that's 32 bytes. If you've got 4 modules, that's 16 bytes. So that's the 2 variables that need to be created there. Then it's a matter of adding that message instruction to your logic program and having a way of triggering it. Now, when you configure that message instruction, how do you configure it? Well, you're going to configure it as a set attribute single message, and you're going to have to set in the details of the instances, class, and attributes, as I've shown on the screen there. You're going to reference the arrayed variable, the byte array variable that contains your configuration data. And then you're going to need to specify a path so that the message knows where that data needs to be sent to, and then make sure that that message is tagged as well. And next, let's talk in a little more detail, actually quite a bit more detail, about the configuration format for SmartRail. So how does that work? Because we've talked about the fact that we need to send configuration data to the ETX250 for the modules, but we haven't really given details on what that is. So the way the configuration works is every module that's plugged into the ETX250 has 4 bytes of configuration data. And as I mentioned a minute ago, if you've got 4 modules, that's 16 bytes. If you've got 8 modules, it's 32 bytes, and anywhere in between, or 1 module is 4 bytes, all right? So the trick, or the goal, is to set each of those bytes to the appropriate values so that each module is set up the way you want. Now, it's not quite as bad as it sounds, because most of the time, a lot of the configuration bytes are just going to be zeros, because the defaults are going to work in a lot of the cases. So one by one, I'm going to go through the different SmartRail I/O modules and what their configuration data looks like. Okay, what those 4 words mean for each of the different modules. So let's start with all digital input modules. All right, so any digital input module we're talking about here. So really, the only thing you could possibly set for digital input modules is input filtering. And you can see the chart there that there's several different values of input filtering that you can select. However, the default of 3 milliseconds is going to be fine in 99% of the applications. So therefore, just leaving all the configuration data at 0 is going to work just fine. So that's very simple. Now let's move to all digital output modules. So whether it's relay output or solid state output, it doesn't matter. They're all the same. Now here, again, 99% of the time, the defaults work fine. The only time you would change the defaults is if you actually want to hold last state on an output when it goes into stop mode, which we almost never do. So again, leaving everything at the defaults of 0, all 4 bytes at 0 is going to work fine for digital output modules 99% of the time. Now, when we start talking about analog modules, then we do need to set our configuration bytes to non-zero values, because at the very least, we need to be able to enable all 4 channels, or enable the channels that we want to enable. So the first byte for any analog module is going to be enabling each of the 4 channels. Okay, so you've got a bit. The first 4 bits are, do you want to enable each of the 4 channels? All right, so if you only want to enable channel 1, you would only set bit 0 here on the chart in the center. All right, so you're going to need to set the configuration to a non-zero value for analog cards. All right, so after the first byte, which is all about the channels that you want to enable, then the next byte is used to set the input range. Okay, so for the ADC 170, that's a voltage or current type module. So if you're using it in 0 to 10 volt mode, you can leave the input range at 0 for each channel. However, if you're using it in current mode, you're going to need to set it to a different value. So you can see that there. And then the third byte of the 4 is for scaling. How do you want it scaled? The default being 0 to 4000, which again works 90% of the time. So most of the time you can just leave that third byte at 0, and then the 4th byte is always 0. So that's the 4-channel analog input module. The 8-channel analog input module is nearly identical. The only difference is you have 8 bits of channel enables, of course, because you have 8 channels. And then you have the next 2 bytes are for configuring the input range, because you can independently set the input range for the first 4 channels versus the last 4 channels. And then scaling is done on a complete module basis. So the 4th byte is how do you want to set the scaling. All right, now let's move into the thermocouple input module. All right, very similar. As you can see, all these analog type modules are very similar. You've got the first byte of channel enable. The second one is going to be something about your input type. In this case, for thermocouple, it's the sensor type. Okay, what type of thermocouple? K, J, T, or R. And then from a scaling standpoint with thermocouples, do you want the scaling to come back in degrees Celsius or degrees Fahrenheit? So that's the question there. RTD, very, very similar. Of course, the only difference is your sensor types are going to be your choice of a couple different RTDs. All right, everything else is the same. Again, degrees Celsius or Fahrenheit for your scaling. Now let's talk about analog outputs. Okay, so with analog outputs, they're similar to inputs in terms of the first 3 words are very similar. Do I want to enable my channel? What's my signal look like? This time as an output signal. What's my scaling look like? But that 4th byte is used for determining what happens to the output signal when the SmartRail rack is in stop mode or not being controlled by the Ethernet IP scanner in this case. So you do have to utilize that 4th byte. Now, if you want it to hold its last value when the scanner goes away, then you can leave that last byte at 0. Most of the time, though, you don't. Most of the time, you're going to want probably a minimum value, which means you're going to need to set a bit pattern in that 4th byte to get the module to go to minimum values on stop. Okay, so those are the DAC modules. All right, finally, we have a mixed analog module, which has 2 analog inputs and 2 analog outputs. And it's very similar from a configuration standpoint to the way that the inputs and the outputs work, just a combination of those things. All right, very straightforward. Next, I'm going to talk about an example configuration that I've got on my bench. And then we're going to walk through in RSLogix software how to configure that. But first, I want to review with you in detail what I've got on my bench. Okay, so here's the bench system. I've got a Rockwell CPU, I've got an ETX 250, and I have 4 modules plugged into it. And I've got those detailed there on the screen. I have a DIM 610, which is a 16-point DC input module, followed by a DQM 602, 16-point relay output module. All right. I've got a 4-channel thermocouple module next to that, and a 4-channel 4 to 20 milliamp output module as the 4th module in the stack. Now, on the bottom there of the gray area where I've detailed what's going on with the modules, I've shown you there for the modules what the data looks like, what the I/O data looks like. So in the first slot, I've got 16 bits of input data, or 1 word. In the second slot, I have 16 bits of output data, or 1 word. And then I have 4 words of input data in the third slot. That's my 4 temperatures. And 4 words of output data in the 4th slot. Those are the 4 analog outputs that are going to be, controlling some sort of actuator or something. And there at the bottom, I've summarized how many input words and output words I have. And so, in effect, I've got a total of 5 words of input data, which is from slot 1 and slot 3. And then I've got 5 words of output data, which is from slot 2 and slot 4. Okay, so the first step whenever you're getting ready to configure your system is to kind of summarize how much input data do I have and how much output data do I have. And if you've used the common modules that we recommend, the 16-point digital modules and the 4-point analog or 8-point analog modules, then you're going to end up with an even number of words. That's the other reason it's good to avoid those 8-point modules or those 8-in, 8-out modules, because then you get this odd number of bytes and it's just more difficult to work with and it's harder to get those modules. Okay, so we've summarized the total amount of I/O data that we have in our test system. Next, we're going to go through and take a look at the configuration data that we want to set for each of our 4 modules. Remember, each module has 4 bytes of configuration data. Now, our first 2 modules are digital modules, and I mentioned earlier that leaving those at 0 is the way to go typically. So that's what I'm going to do here. I'm not going to mess with the input filter or holding last state or any of that stuff. I'm just going to leave all 4 bytes for the input module and all 4 bytes for the output module at 0 from a configuration standpoint. Okay, now when we get into slot 3 for the thermocouple module, that's different. There I'm going to need to set some of those bytes to non-zero values. Now, as it turns out, I'm using type K thermocouples in my bench example, and I'm going to go ahead and accept degree C as my scaling because, in industry, we tend to use degree C more than we use degrees F most of the time. Okay, so what that means is only the first configuration byte for this module needs to be changed to a non-zero value, and that's going to be a pattern of 1111 binary, which is 15 decimal. Okay, in my 4th slot, I'm going to have a 4-channel DAC, analog output. Again, I want to enable all 4 channels in my case, so that's a decimal value of 15 for the first byte. And then 4 to 20 milliamps is fine for the second byte. 0 to 4,000 scaling is fine for the third byte. Now, for my 4th byte, I want the output to go to minimum, or 4 milliamps, whenever I'm in stop mode, okay, whenever that Rockwell PLC isn't controlling me. So that means I need to set my pattern, my bit pattern, as you see on the screen there, 01010101. And if you do that conversion over to decimal, you'll see that's a value of 85. All right, so to summarize my configuration data, here's the table I have here. So my first 8 bytes of configuration data are going to all be zeros because those are the 2 digital modules. And then the next 8 bytes, not all of them are going to be 0 because I've got my thermocouple module and I've got my analog output module. Okay, so those are the values I'm going to set there. Okay, now the tag name I'm showing there of rail config 2, that's just some random tag name that I selected for this table. It could really be anything you want to call it when you go create your tag for configuration data in the Rockwell software. Okay, so next we're going to head to the bench and do our demo. Okay, here's my setup on the bench. I've got my Rockwell PLC here, okay, which is connected over Ethernet IP to my ETX 250, which is also, I'm taking advantage of the built-in switch to connect to RSLogix. And I've got my I/O simulator connected here. And then the 4 modules I have are the ones we talked about that I just ran through in the slides. We've got a 16-point input module, a 16-point relay output module, a 4-channel thermocouple input, and a 4-channel analog output module. Okay, so that's what we're going to set up next. Okay, let's go ahead and configure up our Rockwell PLC from more or less from scratch here to communicate with the ETX 250 as remote I/O. All right, so I'm going to go to my start menu here, and I'm going to find in my Rockwell folder, I'm going to find the boot P utility here first, because the first step is I'm going to assign an IP address to my ETX 250. All right, so I'm going to pick my network interface for my computer, which I've done here, and I'm going to power cycle my ETX 250. Now, in my scenario, the MAC address of my ETX 250 has a A5, so I'm going to be on the lookout for A5 as the last byte or the last part of my MAC address. When I see that pop up, I know that there it is. I know that my ETX 250 is ready to be configured. All right, so let me find it here, right click and hit add relation, and I'm going to assign its IP address. Okay. 192.168.0.110. That's what I want to assign it. I'm going to hit OK. All right, now I'm going to power cycle my ETX again. All right, and make sure that it gets assigned properly. I'll clear my history and look out for it to pop up. When it pops up on the list this time, it should show its IP address next to it of .110. Still booting, of course. As soon as we see that A5, we'll know we're good. There we go, and it's popped up with the appropriate IP address, so we are good. So I'll close out the utility. I'm not going to save my changes. Now let's head into RSLogix 5000. All right, so the first thing we're going to do is we're going to scroll down to our I/O configuration area, and on our Ethernet network, I'm going to right-click and say New Module. This is where I'm adding in the ETX 250. Now, the type of module I'm going to add is a generic Ethernet module. Okay, all right, I'm going to give it a name, ETX 250 in my case. This will be the basis for all of the I/O tags. I'll give it a description. I'll call it SmartRail Remote I/O. All right, now I need to select the data format I want. I want words. All right, so I'm going to select integer from the list, data integer, got it. I'm going to type in the IP address here that I just assigned. Oops, that was a typo. Don't want to let that stand. 168.0.110. All right. Now I need to fill out my assembly instances here. And that's 160 for the input assembly, 170 for the output assembly, and 3 for the configuration assembly. In terms of my sizes, this is the amount of input and output data I have, or input and output words I have for my controller. And in my application, I have 5 words of input from a PLC perspective and 5 words of output from a PLC perspective. So that's what I want there. All right, so that's complete. And my configuration, I leave at 0. All right, so that's been added. Now, if I take a look here at my tags, you can see ETX 250 input and output tags have been added, 5 words each, okay? And of course, we haven't, got our configuration set in our controller or anything yet. So let's go ahead and now go to the step of getting our configuration data ready. Now, if I was using purely digital input and digital output modules, I would not need to do configuration because the defaults for digital input and digital output modules are fine. There's no reason to change the configuration in 99% of the cases. So I'd be done if it was nothing but digital I/O, but I do have some analog in my example. So we need to have some configuration data for that. All right, so let's go ahead and add a couple of tags that we're going to use for configuration. The first one is a tag that I'm going to name ETX message, which is going to be of the message type. Okay. And then I need another tag to contain all my configuration bytes. And in my application, remember, I have 4 modules. There's always 4 bytes of configuration per module. So I'm going to need 16 bytes of an array of 16 bytes long for my configuration data. So I'm going to call this ETX config. All right, and this is going to be single integer with a dimension of 16. So it's not single integer, it's SINT is the abbreviation for Rockwell. These are bytes. So 16 bytes long. All right. And that should be in there now. All right, so I've created a tag for my message, and I've created a tag for my configuration data, which is what the message is going to send. All right, so let's go over now to our main routine, and I need to create one more tag in my main routine area. This is going to be just a Boolean bit that's going to use to trigger my message. So I'll call this send ETX config, and it's just a Boolean bit. All right, so that's the bit I'm going to use to send my message. All right, now to the main routine. I'll right-click and hit Add Rung. Let's add the bit that's going to trigger our message to be sent, which is send ETX config. Okay, and then let's add an instruction here. And that's going to be message type. All right, and we need to assign to it our message array, which we did. All right, now we can go in and configure it. All right, so we do want a SIP generic message, but we want a set attribute single down here. Set attribute single. All right, our instance is 180. Our class is 4, attribute 3. Source element, this is where we type in our array that contains all our configuration data. So this is ETX config. Okay, that's fine. I hit enter. You shouldn't hit enter until you're really done with complete configuration. So my bad. All right, ETX config, source length of 16 bytes. Remember, configuration data. Every module has 4 bytes of configuration data. I have 4 modules in my example. That's 16 bytes of configuration data. If I had 8 modules, it'd be 32 bytes. If I had 2 modules, it would be 8 bytes. Okay, so I'm done with this tab, but now I need to go to that communication tab and set the path. And I can browse for it. So there's my ETX 250 module. All right, and then under tag, I need to make sure that's tagged, and it is. So I can say OK. All right, so that's complete. All right, so I've got my tag. I'm sorry, I've got my program done here for my message. The last thing I need to do is to set the values for the bytes in my configuration array. So I'll go back under program tags, under monitor tags. All right. And actually, I need to go online first, don't I? All right. So let's go online. We're going to download our program we just created. Okay, now before we actually go in here and set our, oh, you dummy, you didn't set your, oh, that's the send ETX configuration. I'm looking in the wrong spot here, aren't I? I need to go up a little further. There we go. Under controller tags. How about that? All right, there we go. There's our configuration bytes. All right, and monitor tags. You can see I'm not the swiftest guy with Rockwell programming, but I'm getting there. Okay. All right, so let's set up the configuration bytes that need to be changed from 0. Most of them are going to remain 0 to get the configuration the way we want. Okay, so the first 8 bytes are going to be zeros because those are all digital I/O modules. Those 2 are digital I/O modules. Next is our thermocouple module. We want to enable all 4 channels, so that means a value of 15. Okay, and everything else in my example, the defaults of type J thermocouple and degrees Celsius are fine. Next, we need to go to byte 12, which is the start of our analog output module. We want to, in my example, I'm going to enable all 4 channels. That's, again, a value of 15. And then everything else is the same, except I want it to go to minimum value on stop, which means a value of 85 decimal. Okay, so now I've set the configuration data the way I want, but I haven't sent it yet. I haven't generated a message and sent it yet. Because remember, that bit that triggers the message hasn't been turned on yet. All right, so let's do this. Let's go to the back here to the controller tags under monitor tags. Let's take a look at our ETX 250 input data and see if we're getting values. Hey, sure enough, we are. As I change my digital inputs on my simulator, you can see they're changing. Okay, so that's coming through just fine, but you'll also notice that all 4 words coming back from my thermocouple module are zeros. That's because all 4 channels are disabled because the configuration message hasn't been sent yet. So let's see if we can get that configuration message sent and see if we get some real data back. All right, so let's go to our main routine. And I haven't added any logic to trigger this bit yet. So that'll, of course, have to be done in a real application before, you really are finished. But I'm going to go ahead and just right-click here and say toggle bit. Okay, my enable and my done are on. That's good. I didn't get an error. So it looks like that message went through as planned. I'll go ahead and toggle that bit off again. And now if we go back to our controller tags, monitor tags, let's see any differences. Yep, sure enough, there we go. So now I have an open circuit on my last 3 channels. That's why I have the minus 2700 there. And then I'm getting a value on my second channel, which actually has a temperature probe connected to it. And it looks like it's sitting there at about 31.2 degrees. Terrific. So everything's working as I planned. On the output side of things, of course, I don't have any logic to do anything with the outputs yet, but I have the ability. Remember, my first output is a relay card. I could manually turn on, let's say, the first 4 relays, and maybe we can hear the click. Should be able to hear the clicks there as those relays turned on. And so that's working well as well. And then these are my 4 output channels for my analog output, scaled from 0 to 4000. So if I wanted a 20 milliamp output here, I would set this to a value of 4000. And then I could put my meter on that analog output and verify I'm getting 20 milliamps, et cetera, on the first channel. Okay, so that is kind of a start to finish, more or less, configuration of SmartRail for the Rockwell PLC as remote Ethernet IP I/O. All right, this is the part of our program where I remind you that we're here every Tuesday at 2 o'clock, whether we're fully live or streaming a pre-recorded video to you live, always with somebody standing by ready to answer your questions from the chat section, or if you're watching on replay, give us those comments and questions in the comment section, and we'll get back to you very quickly. Okay, next week, we're starting a 3-part series on OCS-I/O, starting with the Universal Analog Input Module. So you don't want to miss that new 3-part series on OCS-I/O. Also, we're celebrating 10 years of the Horner Lighting Group. So don't forget, there's plenty of videos on our Horner lighting products available on the Horner APG YouTube channel. If you haven't done so already, don't forget to subscribe to our channel. It doesn't cost anything. And if you choose to subscribe and choose notifications, you'll be notified every time we go live or every time we post a new video. Okay, so until next week, let's all get out there and do us some good.